Hello there, I'm Steve from Mac84, and today we're going to be looking at an Atari 800 8-bit computer. My Atari 8-bit computer just doesn't want to work anymore, and I believe it's because of the capacitors. I found this Atari 8-bit computer for sale locally for $10 back in 2018, but I never got it to turn on. So what I'm going to be doing is recapping the power supply and the main logic board. There are 8 capacitors on the power supply, and there are 2 capacitors on the logic board. Now, I did buy a recap kit from console5.com. This is not a sponsored video, but that's where I got the recap kit from. And I didn't really find any other information about this. There was a schematic, but for me, I usually work better with the recapping diagram. So I'm going to share my recapping diagram as I go through this video, and it'll probably be in the video description text box as well. But let's have a look here. We have our power supply with the capacitors already removed. And so those are 8 capacitors there that had to be replaced. And then we have our main board here, which has 2 small capacitors that need to be replaced. One is located here, and one is located right here. Although recapping your Atari is a good place to start, you may also want to check your AC power adapter. These adapters can be more than 40 years old at this point, so it doesn't hurt to test it and replace it if necessary. These are the capacitors I ordered from Console 5 to replace the capacitors in my Atari 800, so hopefully this will get our Atari working again. So let's dive right into it. First things first was removing the existing capacitors. This actually wasn't too hard because unlike the computers I'm normally recapping, this board has big traces, big pads, and the capacitors are actually big enough to hold in your hands. So you can actually wiggle them out of the holes if necessary. This didn't take too long, and it was actually quite pleasant to do. You'll notice that some of the older capacitors are much larger than the newer capacitors. You'll also see on the 4700 microfarad capacitors that there used to be 3 poles, whereas the new capacitors only have 2. However, you don't have to worry about this. You could use these new 2-pole capacitors without issue as long as you plug them into the right spot. Now is the time where I remind you that there is a recapping guide linked in the description of this video. I highly suggest you check that out. So what we'll be doing is just placing the new capacitors in. The stripe on the capacitor signifies that end is the negative end, so the other end is positive. And this board has a plus marked where the positive is. Now you do see we have 2 sets of holes there. Only 2 are visible. This just means that this area can accommodate larger or smaller capacitors, depending on the pitch between the pins. But we don't have to worry about that since we're using smaller ones here, which should fit into the middle holes. So we're going to place the capacitor through and make sure it is flush. And then we're just going to bend the pins on either side to keep that capacitor in place so we could solder it without issue. We'll do the same with our other capacitor, again noting the polarity of the capacitor and making sure that it is correctly positioned. Now we do have some gunk and grime on the bottom here, so we will be cleaning that up before we solder these capacitors in place. There, that looks much cleaner than it did before, and we're ready to solder our capacitors in place. I'm just going to add some no clean flux to these solder pads here. And now we'll solder the capacitors to the board. Now that everything is in place, we could clip off the excess legs of these capacitors. Okay, these look great. Let's move on to the rest of them. These capacitors are typically referred to as axial capacitors, and they do sit on the board as well. However, these legs go through those holes and the capacitor sits flush. So to bend these legs, you just want to take a pair of pliers and bend them. You also want to make sure that the polarity is correct. Again, we have the negative marking shown here, pointing to the negative lead, and the positive lead is on the opposite side. So I'm just going to take a pair of pliers here. I like to bend them so that the rating is pointing up, so if anybody has to replace these again in the future, it's easy for them to do so. And I'm just going to take a pair of pliers, gently turn them. We're not crimping anything too hard here. Those legs are now bent. If you have to adjust them, they are very flexible, so you could do that in the future. And we should just be able to adjust this in the right spot. And since those holes are clear, the capacitor will fall into place. And again, we're going to turn the board upside down, and we're going to just bend these pins so that capacitor stays into place so we can solder it. And we're going to do the same with the matching capacitor here. So now our capacitors are secured and they're ready to be soldered to the board. The next two capacitors are C201 and C202. They are the same, so you can't really mix them up. We're going to follow the same steps as before, bending each leg of the capacitor, placing it on the board, and then soldering it into place. Now we're down to the final two capacitors, again repeating the steps we did previously. Alright, so we've replaced all 8 capacitors on our Atari 800 power supply board. Now is also the perfect time to double check the polarity and placement of each capacitor that you installed, to make sure that there are no mistakes. This only takes a few seconds and can save you from a lot of trouble down the road. You may also want to gently wiggle each capacitor to ensure it is secure and that you don't have any bad solder joints or places where the solder didn't hold as you expected. By taking these few extra steps, you get the chance to inspect and redo any work before you reassemble the computer and power it on. Before we move on to the main logic board, we have to put the heat shield back on our power supply board. If desired, you can replace these two voltage regulators with modern ones that may not run as hot. I'm going to use the existing ones for now, but I'm sure somebody in the comments section here or elsewhere online can help point you in the right direction if you want to replace them. When replacing the heat shield, be sure everything is tightly secured. This will ensure that these regulators can transfer heat effectively. Now we just have to replace the two capacitors that remain on the main logic board. The first capacitor is number 179 and is located here. The second capacitor is number 199, which is partially hidden behind the plastic over here. To get access to these capacitors, we do have to remove the plastic top and the bottom metal shield. The top plastic and the bottom metal shield here are connected through the board with 4 plastic clips. Those clips are located here, 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 and here. To release these plastic pegs, take a small screwdriver or a pointed tool and press down on the middle peg firmly but gently. The middle peg will push down, allowing the surrounding plastic pedals to move freely. Then, take a screwdriver and lift up the board. Now just repeat these steps. Now we can separate the board from the metal shield below. Next, we'll remove the plastic tray for the cartridges and memory cards by releasing the plastic clips beneath. Just carefully push in these plastic clips with your fingers to release them. The plastic tray is now free and you could remove it from the board. Now that these pieces have been removed, we have easy access to the two capacitors that we have to replace, capacitor number 179 and capacitor number 199. First, I'm going to add some fresh solder to these joints. This makes it much easier to remove these components, especially since they're held in with 40-year-old solder. This one was being a little stubborn, so I've added some flux here. I'm also using my clippers to just pry the capacitor off while I heat the leg. That helped quite a bit. Although it is more uncommon for these axial capacitors to leak, this one has. So there is some residue here that we'll have to clean up before we put the new capacitor into place. Ugh, look at that. Yuck. Finally, it's time to install our last capacitor. Pay close attention to the polarity. The gray stripe on the side of the capacitor points to its negative leg. Okay, great! Both of our capacitors have been replaced on the main board. That means our recapping is complete. Now we just need to reassemble the computer. But before we do that, we'll just dust off a few areas here which have some 40-year-old dust bunnies hiding out. Now we need to reassemble the system. First, we'll need to get those plastic pegs to secure back to the board. This can be a little tricky at first, but just take it slow and you'll get it to work. Essentially, you need to push in the center stem so it's fully removed from the surrounding plastic pedals. A small screwdriver or a tool like this should work fine. Keep the stem attached but withdrawn from the center. Don't worry if the stem falls out, you can easily guide it back in. Then, push the pedals together and rock or rotate them gently to guide them through the hole. Once they're through, you'll need a tool or a hard object to push the stem back into place. Once the stem is pushed in, the plastic peg is secured, and you can repeat this process for the rest of them. Next, we'll need to reinstall the plastic memory and ROM holder. Simply place the plastic pegs over the holes and push down firmly but gently. Now we can insert the main board into the bottom case. Pay careful attention to how you insert the controller ports into the bottom first. Now we'll reinstall the RF shielding. Be very careful to align this correctly, as the power supply in the top case won't sit correctly if this is misaligned. You can use the screw holes on the bottom case to help you line up everything. Now we'll reseat the power supply. The pin header from the logic board connects to the power supply by pushing down through the bottom of the red connector. It's a bit difficult to feel if this is secure, but if it doesn't easily lift up from the board, you should be okay. Be sure to plug in the 4-pin cable as well. When connected to the power supply, the purple cable should be facing the controller ports on the front of the system. Now secure the power supply board to the RF shielding using the 3 appropriate screws. There's one in the front, one next to the RF jack, and one towards the back. Now reinstall the RAM and ROM cards to the system. My cards unfortunately don't have their original plastic cases, so it took a little bit of guesswork to get it right. Lastly, install the ROM card. Now, hopefully your ROM card doesn't look like, well, this. First off, the plastic case is missing. Second, well, the more obvious thing is it's modified. This has a board that sits on top of the original ROM, and this board has a half-dozen wires that run to a pair of switches on the front of the system. This whole thing probably has to be rewired, but I think that's best suited for another video. Your typical Atari 800 should look like this, give or take some RAM cartridges. Now reconnect the keyboard cable. Don't forget, there are 2 screws that secure the keyboard to the top of the case. Alright, this is the moment of truth. Let's hope it doesn't blow up. Still no light. Ah, I know why. We need the lid. Why do we need the lid? Well, there's a little switch on the power supply board here that detects if the top door is open or not. And this little piece of plastic here activates that switch. Without that, the unit will not turn on. To test this, I'm just going to use a screwdriver to push this switch down. There we go. That's what it was. Alright, so let's reinstall the door and try it again. Okay, what's all this then? So the good news is we did get the Atari to work. Replacing the capacitors let it fire right up. The only problem is that our modified ROM, well, it's a little finicky. It does work, it does turn on, but after about a few seconds it just gets garbly, and I'm not exactly sure the position of where these switches should be. All I know is that I keep fiddling with them and eventually it'll work, but then sometimes if I turn the machine off and then turn it back on, I get the same problem. So there might be something wrong with the way it is wired, or with one of the chips, or whatever. Thankfully, a replacement ROM isn't too hard to find or too expensive, so I may be investing in one of those, but for now I could use the 10K ROM out of the other Atari 800 I have, and this will work just fine. Don't forget to stay tuned, because I do have another video coming up soon about this Atari 800 and that weird ROM modification that we saw earlier. If you enjoy these types of videos, please consider subscribing to the YouTube channel and click that little like button as well. If you want to follow me on social media, I'm on Twitter and Instagram on the handle Mac84TV. You could also support me directly on Patreon. For as little as $1 a month, you get exclusive access to goodies, discounted shirts, and other stuff you just can't get anywhere else. But that's it for now, so I'll catch you later. Thanks for watching, and I'll see you right here next time on Mac84.